time for another Intrepid Museum Astro Live. You know the drill. We do these on a regular basis where we have cool guests and engineers and scientists, and sometimes we even go cool places if you're around last month. But today we have some interesting things to talk about. I like to think we always have interesting things to talk about. But we are going to be diving in to how we protect humans from extreme environments. Think about this, right? You go down someplace. Maybe you're just going out to the beach. Maybe you're going out, I don't know, into your yard or something. How do you protect yourself? What do you do if you're going to the yard? Big thing is you wear clothes, hopefully, usually. You go to the beach, you're going to put on sunscreen. You wear a hat, shoes. You're walking around and you're putting things on your feet so that you're not cutting your feet while you're walking around the store or whatever, right? All the different things you do in your daily life to protect yourself. Not always from an extreme environment, but just an environment, right? Well, what happens when you get into more hardcore environments? What happens when you go into the vacuum of space? What happens when you go down to the ocean and you have 80 bajillion gallons of water crushing down on you at extreme pressures? Well, that's what we're going to be talking about today. We actually have a little bit of a thing. If you've ever been to Intrepid Museum, you know that they do science demonstrations. And one of the demonstrations that I've had the pleasure of seeing at the museum is one that shows how your body might react to a vacuum. You'll ever seen the thing with the marshmallow, right? And there's a little vacuum pump. The orange thing is a vacuum pump. There's a jar behind it, and that's a regular Mark I marshmallow that they've put on the vacuum chamber there. And you put the glass on top of it, and you start to remove all the air. It's not the beach, it's not your yard, but it's like space. You create a vacuum like outside the International Space Station or on the moon or whatever, right? Well, as you start to suck the air out of this vacuum jar, what happens to the marshmallow? Well, watch it and think about whether you'd like your skin to be doing this or your eyeballs to be doing this while you were out in space. Slowly but surely, I think it actually has audio in it, but we're not going to play the audio because the pump's like, brrr. But it gets bigger. And then when you let the air back in, you saw the hand pull the little pump out, it shrinks down again. Well, that wouldn't feel very good if that was your body, if that was your skin or your eyes or I guess your nails or whatever, your feet or your hands. And look at what it's done to the marshmallow. So what we're going to be talking about here is the things that we can do, maybe make little special suits or personal spacecraft or whatever you want to call it, to protect the human body from extreme environments so that you don't crumple up like a marshmallow or explode like a marshmallow. That experiment also works really well if you use a peep, you know, like the little Easter candy. Anyways, y'all know how it is. It's a virtual Astro Live, so it's not just going to be me talking at you today. We will, of course, be joined by the wonderful Alicia Siegel. Alicia, would you have you on the show?
Hello, yes you do. Hello, hello.
I like how it just like slides over.
I just appear. I just magically appear. And I love showing that demo. I recorded that during the pandemic and I was doing that for virtual programs. And it's just such a great thing. It's called Poof Life in a Vacuum. We do it all the time at the ship. And yeah, if you imagine the marshmallow as all of the flesh and tissues and muscles and guts of your body,
Yep.
it's kind of got that squishy structure, right?
It's a little
But it's
squishy.
made up of sugar and water and air. And so when you take all of the air, when it expands, all the air is coming out of the pressure chamber there. And the air pockets themselves, they expand, they get bigger and bigger and bigger as you saw the marshmallow get bigger. And then they burst and it kind of levels off. And that would essentially be your body. So
Yeah.
it really is just kind of going up to that point, reintroducing the atmosphere. Obviously, that's not in the vacuum anymore. But that's why you need to wear a spacesuit because your body in the vacuum of space wants to expand without all that pressure. Your
Yep.
blood's going to boil off and evaporate. Your lungs are going to swell up and, any air left in it, it wants to get out and it'll burst. So yeah,
We don't want to do that.
in your spacesuit. Yeah.
That was your hand, like in the video. That
Yeah,
was
that
a
was me.
guest appearance by Alicia's hand.
That was my hand like 5 years ago. Yes.
In the other end of it, when you removed the tube from it and you let the air back in, that was just letting in normal atmospheric pressure, but it was also illustrating a pressure differential. It went from a lower pressure, the vacuum, to a higher pressure, the normal air, and that's what can happen whenever you go down to the bottom of the ocean. You go from normal sea level to a higher pressure environment, and then you get that little raisin shrink sort of thing. In the other direction, space is a vacuum. Under the ocean, like the exhibit that's at the museum right now, you can actually get sort of crushed like that, right?
Yes. Well, that's a great segue. As you all may know, back in June at the Intrepid Museum, we opened up a brand new exhibit called Mysteries from the Deep Exploring Underwater Archaeology, which I will talk a little bit more about at the end of the show. But we've been making some sea and space connections lately. As Das mentioned, you might have tuned into our epic Neutral Buoyancy Lab episode last month, for example, where we
Yes.
went on site and gave a tour and met so many amazing people and saw such cool stuff. So be sure to check that out on, all the interwebs and all of our channels and stuff from last. There you go. This is the exhibit,
There
by
you
the way,
go.
information.
Cool.
But this month, we thought we would take a look at some of the protective suits that humans have to wear to be able to explore extreme environments. Obviously, it being Astro Live, we're focusing on space suits this
Yep.
month. Specifically, we'll be talking about ILC Dover's new Astro Suit prototype. But there is actually some overlap in this idea of protective wear between what they wear in space and the exosuits that people also wear when they're working deep underwater to
Yep.
explore, those really deep pressure-filled depths. So, first of all, for those of you who aren't familiar, and of course, our guest is going to talk much more about this, ILC Dover is essentially the company that's been making spacesuits for NASA since the Apollo era. So all of those suits, those white suits that you saw bouncing around on the moon
Yep.
during the Apollo era, all the way up through really the ones that you see doing EVAs on the actual
ISS.
right now, that is ILC Dover. That you don't really see their name very often, but they are the contractor that makes all those NASA suits. So they have a really rich history in creating these things, and I think what better person to bring on? Shall we bring him on now?
We should.
Um,
We have an actual spacesuit engineer with us today, don't we?
Too. And so we have with us Connor Chappell. First of all, also want to mention last month when we went to the Neutral Buoyancy Lab, we also were extended this amazing once in a lifetime, maybe, I mean, I don't know, maybe you'll invite us
I mean,
back,
hey.
but this amazing opportunity to go to ILC Dover and actually go inside of one of these amazing Astro Suit prototypes, which is just over his shoulder right now. Thank you for that amazing opportunity. I still can't get over that. I had to get an FAA flight physical at like the last minute to be able to do this, but I got, pressurized in the suit, and you'll see some footage of it throughout the program today. But anyway, they're based in Houston, Texas. I mentioned, they have been in this industry for a very, very long time. And Connor is a project engineer at ILC Dover. He actually, in that live stream, you can, again, after the show, go check that one out on the NSF channel. That wasn't on the Intrepid channel yet. But he popped in every so often during that stream from there. So we're really excited now to be able to pick his brain a little bit more this month. He specifically actively leads and supports engineering projects in the human spaceflight industry. He's currently working on the EMU spacesuit that we featured, but also what's really neat about having him on our show right now is that in a past life, he also worked for Oceaneering and has a degree in ocean engineering. So who better to have on this particular show, talking about spacesuits, of course, which makes sense for Astro Live, but also to make connections to how they are informed by working with other extreme environments like in the deep sea.
Yeah.
So
Connor,
I'm gonna stop talking. Let's
we
bring
promise we're going to let you talk, Connor. We're going to let you talk some.
Oh, it's perfect.
Welcome to the show. We appreciate you taking time out of your weekend to hang out with us.
Yeah, well, thanks. I'm glad to be here. It's a great afternoon, and I'm excited.
All right, good deal, folks. Some real quick housekeeping. When we were trying on the spacesuits, Connor was there. He was there. He actually set up most of this stuff for us. But we were so excited by trying on the spacesuits, we didn't do a lot of Q&A with the audience. So today is your chance. If you had a question that maybe we didn't get to during that show, or as we're talking through here today, tag us in chat. Whichever stream you're watching on, if you're on the Intrepid channels, you're on the NSF channels, just tag us and we will get some of your questions, because last time I know we didn't do as much Q&A, but let's hop right in and talk with Connor about his work on spacesuits, shall we? I don't know who I was asking. Yeah, who was I asking there?
Yeah.
We're going to hop in and talk to Connor about spacesuits. Connor, have you put on the spacesuit yourself?
Oh, yeah.
Oh, yeah.
Yeah. I think it's like one of the first things we like to do is if the engineer is capable, is to get them in the spacesuit. There's no other better way to get the experience of know what you're designing, know what the astronauts are going to be wearing, than to do it yourself, right? And that also helps in that iterative process, right? Is hey, my arm felt a little funky over here. Let's try this different combination, So it's the first time I was in it. I was just head over heels, just so excited. And I said, every single person that works here needs to do this, if able. And we've had people all the way from in different departments that aren't even really in the spacesuits.
Right.
So try them on, right? And it really just brings it home as this isn't just a pair of clothes. It's not pajamas. It's a real life spacesuit, right? This is a pressure vessel.
Even the pajama part of the spacesuit is special pajamas because it's like liquid cooled pajamas, right?
Oh, it's the nicest pajamas.
Let's see here. I think that's one of the interesting things here because there's this conception, right? Oh, the only people who ever get in spacesuits are they're the best of the best, are the NASA astronauts, the fighter pilots and test pilots, all this sort of thing. If you think about who went to the moon and that sort of stuff, right? And it's interesting. As we move more and more people into space, it's not just the fighter pilots, it's not just the test pilots that are going to space. It's getting to be more and more, I want to say normal people, right? Clearly highly skilled, highly talented people, but the more people who go to space, the wider different types of people you have. So I think it's really interesting that you get normal folks from around the office to try on the spacesuit and give feedback because we're not just, the grin and bear it hardcore astronaut who can deal with anything, right? Getting regular people into spacesuits is an important part of the design process, I feel like. Does that make sense? Or is it like, no, you have to be specially trained to put on this suit? I think I know
Well,
the answer to that. I
yeah,
wasn't
no, I
trained.
don't. There's no special training, right? But just like we saw with Alicia, there's some kind of intuition on how to react and how to move the spacesuit. But there's also a little bit of a learning curve, right?
Yeah.
We call it programming on how to rotate all the joints correctly and be really proficient. That's one of the things that astronauts are really good at is sometimes being really picky on you want the best fit possible. Because as whether they're test subjects or astronauts, whoever they may be, if you're going on an EVA, you're going to be out there for quite a while, right? So you want to not overexert yourself. If you have a small pressure point somewhere, you
Yep.
probably don't even want that because 8 hours from now, it's might give some bruises or it might be a hot spot. So
Yeah.
um,
Who's done that, right? Like you've put on a new pair of shoes or hiking boots or something, and you're like, they're fine. But there's like one little problem, like one little uncomfortable bit. And I guess I'll wear these on my trip today. And then an hour, 2 hours into the trip, you're like, geez, this is actually a lot worse than I thought it was. The same sort of thing with the spacesuit. You have one little part that doesn't fit quite
But
correctly.
but I think what's really remarkable about this particular one, and just to be clear, everyone, this suit that we're showing you right now and the one that we're talking about, this is their new Astro Suit prototype. So this is something that they now have made commercially available. They're still kind of tweaking it and working on it, I believe, but it is a really remarkable suit because it's very adjustable. Like this is like, Das is talking about how anyone can get in the suit now. You don't necessarily have to be, NASA trained, whatever. That's kind of the point of this. This suit is remarkable because all the pieces are interchangeable, or most of the pieces are interchangeable with the arms and the legs and stuff. So I had on the suit, and then actually Das put it on too. They changed out the lengths of, some of the arms, the bearings and things.
Yep.
There you go,
Oh,
perfect.
yeah,
So you
look at
can
that.
actually see this range of different lengths and sizes to be more accommodating for all different body shapes and types. And I believe, Connor, weren't you saying they were saying that there's like a percentage that it now can fit of like average human body types and stuff?
Yeah. So just like with every spacesuit that's ever been made, right? It has a design requirements. Who do you want it to fit, and how do you want it to fit, or how do you want it to operate? So this is, like you mentioned, a commercial advertised suit, and it's designed to fit the first to 99th percentile of adults. We don't make kids ones yet. Maybe soon. So it does have a huge range, and what you're kind of seeing on the screen, right, is that adjustability of you want to be able to move bearings around to fit any size body. So right there, you're seeing the side bearings, or the bearings that are on your shoulders, go in or out or at different angles, right? And that's kind of one of the bigger new advancements of the suit you're seeing, is that adjustability, and you can do that without changing the entirety of the torso,
Right.
which is what's required today on the space station. But it does require a lot of measurements. So you'll see, Alicia, I think you got measured, I don't know, 50 something times or something.
Yes, there was a whole measuring process that both us and I went through the
Yep.
day before. So many different, got rulers and calipers and things measuring just very minute little details, yeah, of all of our body to make sure that everything fit properly and, they could interchange those pieces, which is important, as more and more people in different body types and shapes are going into space. there was that story, of course, the women on the ISS, they didn't have the right suits, so they couldn't, do their EVAs and everything. I think that's unacceptable. I think we should be able to have pieces that are interchangeable and can accommodate all
Yeah.
different sizes.
I think they're, at least if I remember the story correctly, they had the right suits, but it would have taken a long time to modify them. And so
Sure.
they couldn't get that done before the EVA. But that's why it's so important to be able to quickly change the suit. It's not like, oh, it's 12 hours worth of work to
Yeah.
reconfigure this suit so that the astronaut can do the EVA. It's 1 hour worth of work or something like that. If I recall correctly, they had the right sizes up there. They just didn't have, I guess, the time to reconfigure it the way to make it comfortable for those astronauts.
Yeah.
Yeah, every time you take it apart, if you break any pressure barrier, there's checks that you have to do afterwards
Yep.
to ensure those pressure barriers are now sound and safe to operate. Right. So, like you said, it takes a lot of time. But it's, like you said, it's personal though. Like you got a lot of measurements to make sure you get that accurate fit, and that's the important part. Is having that proper fit, and because that's gonna give you the most dexterity and the most proficiency whenever you're operating in space, in the ISS, or on any planetary surface as well.
Yep. Hey, real quick, let me hop into a couple of questions here because there's a couple interesting questions in chat. Connor, we're going to start with an easy one. When you put on the spacesuit, do you make robot noises when you move your arms?
I think most people might. If it's not in my own head, it's maybe out loud. Yeah.
Like, like sort of thing. Do people have a tendency to try and do the robot when they're in the spacesuit, right? Like the robot.
I think I did. I think I did. I was dancing. I think I did the Macarena at one
You
point.
were doing the Macarena, and I think we showed it live on stream when you did that,
Yeah.
didn't we?
But
Yeah,
that just goes to show you, like, there actually really was a huge range of mobility.
Yep.
The older suits, they really, you see, I mean, I wasn't in an older suit, but you see how, like, stiff and everything. And this really is remarkable, all of the different bearings. How many different, like, joints did you guys say that were on that you could move every other little angle of yourself? I just did a
Oh, I'd have to count them, I guess, or it's right behind me. But
Counting 1, 2, yeah.
yeah, you got shoulder bearings, arm bearings on your bicep. You have wrist bearings. In this suit behind me, you have hip and thigh bearings to add for that or the leg mobility. You don't need a waist bearing anymore. The
Right.
current suit on the ISS would have a waist bearing instead of those leg bearings. And then you have other soft good joints that instead of rotational joints, you have more soft goods like the elbows, the shoulders, the knees, the ankles. Right, those are the waist, especially.
Right.
Those are all soft good joints.
Gotcha. What the difference? Let's talk about the difference real quick. A soft good joint versus a bearing joint or a rotational bearing. A soft good is just like I don't know, a plastic bag or a balloon or something. Like you can bend the balloon. Like think of a balloon animal, right? You can bend the balloon, but it's not as good to rotate the balloon, right?
Yeah, torsional soft goods is a pretty hard one to do.
Yeah.
So any rotational, you'd have just typical bearings, right? A hard metallic bearing.
Right.
Now that has its pros and cons, right? There's obviously weight involved with that, and that's one of the biggest things on this suit, right? Is we moved away from a lot of heavy stainless steel appliances to aluminum or whatever else. So, but like your elbows, right? Like we mentioned earlier, this is a pressure vessel.
Right.
So I'm maintaining that amount of pressure inside at all times. So if I bend, so like a balloon animal, if I bend something, you'd be decreasing the volume, which would be increasing the pressure. So you have to move that volume somewhere. So whether it's convolutes, gores, pleats, different ways to kind of fold up the fabric, if you will. As you can see, like on the elbows right there, there's enough fabric to bend your whole elbow 90 degrees, and then obviously straighten it back out, right? So you are fighting that pressure, but those joints make it so that it's like almost a neutral amount of force to apply.
Because the internal. Go, Alicia. Yeah.
I definitely remember that. When it was pressurized, obviously everything stiffened up, but at the same time, it also gave me something to work against so that it made more sense when I was moving. It felt like it was all my arm, for example, or, my leg, and I could actually bend. Oh, that was when I threw the baseball at the camera. But
did we hit the camera?
Yeah, but what you're seeing right now, this is me in the suit, fully pressurized, off the stand. I am supporting it all on my own. It was actually not not as heavy as it looks at all.
Yeah.
And you can see the incredible range of motion. I got down on my knees and touched the floor earlier with that. And that's not something, that I think astronauts could do before gracefully. I don't know that I was graceful when I did it either, but it was easy. I mean, it was heavy, but it was easy. So so yeah, we're throwing balls at each other here. This is like, I'm moving, and it was really remarkable. I was able to move a lot easier than I was expecting with it.
Yeah. The other thing here, and Alicia, this probably gets us into a conversation. Have you ever been to like the Kennedy Space Center visitor complex? Right. And they have an astronaut in what seems to be an EVA suit walking around, but it's a theme park suit. It's not a real suit. It's one that's designed. It doesn't need to be pressurized. It's like they're wearing it, right? Versus here, what Alicia is wearing, it's the actual suit. It's a real spacesuit. It's tethered with an umbilical, wasn't it, Connor? And it was pressurized. Like, this is the way the suit is supposed to operate, right?
Yep. That was running at full operational pressure, what you'd see today on the ISS. Yeah, so like you said, those other ones you see at the park or whatever is, I would refer to them as costumes.
Costumes.
You're not sealing it up and pressurizing it. It would be more of an analog or a costume kind of
right.
But yeah, you're at full operational pressure right there. Yeah.
And
wearing
how much, do you
a real
remember
spacesuit.
how much pressure they pressurized it to inside?
4 point.
I remember a 4 in there.
Yeah, you're at about 4.3, 4.5 psi.
Yeah.
Inside
And
of
so
there.
that whole process, I remember when it was happening, it was like a slow, they slowly build it. And I had to kind of keep clearing my ears. If you've ever been in an airplane, obviously when you go up and the cabin pressurizes and everything, your ears might pop, or, when you come back down and everything, or scuba diving, that we were making that example last month as well. So I had to kind of, equalize a yawn every so often to pop my ears, but it was actually pressurized inside.
Yep.
And then when you guys took the glove off at the end to sort of, have that one small point to depressurize it, there's like a little pop because all the air came out too. And I was like, oh, okay. But it honestly didn't feel any different inside of it at all. I could feel, there's like the fan and of course the cooling garment. And we talked a little bit about that. I think we also have footage of that as well later, but it didn't feel, everyone was asking me afterwards too, like, what did it feel like? It honestly didn't feel any different under that pressurization.
Right.
Yeah, your skin doesn't feel much different or anything. Like you have a normal amount of air to breathe, right? And like you were saying, that when you we call it pop the glove to release that last little bit of pressure, we're still giving you air the whole time through the vent pad in the neck, and so it'll have some residual pressure. You can't always get to zero. You'd have to turn off the fan, and obviously we don't want to do that.
We want to like pull a vacuum in the spacesuit. That's not what it's designed for.
Yeah.
Yep. Yeah.
That cooling garment too underneath. Dawson and I were both commenting on how actually very comfortable it was.
I liked it.
Very cool. Like there's tubes running through that. The first thing also, if anyone's ever seen that, maybe we sometimes will bring in one of those during Kids Week or something at the Intrepid. Yep. They look very fragile, and they look like pantyhose or something, and I was always so scared to like, oh, am I gonna break it, whatever. And so you guys gave this to me to put on, and I'm like, oh, I'm gonna rip it. I have to be so careful, like my nails might scratch it or something. It is durable. That thing is really, really durable, and it stretches too. I was like, is this gonna fit me? I don't know, and it really stretches. But it was just also so nice, like running that cool water through it. It felt wonderful. Yeah. I kind of want to take it outside on a hot day.
Connor, do you have one of those there? I think you have an LCVG. Is that what it's called?
Yeah, the liquid cooling and ventilation garment.
Nice.
I have one right here. I'm not sure how well it'll come through.
Oh, that's fine. We see it.
Just like the one you're wearing. Yeah, it's got like a spandex and a chiffon kind of liner. So it's real soft, real lightweight. Like you said, it's super stretchy. Let me switch it this way, maybe.
There you go.
Show you. But just like your water-cooled computers, you're water cooled when you wear this, right? They have all the lining of all the tubes inside of them. It's kind of hard to see on this image, but this is plugged into the spacesuit, providing cooling at all times, right? We'll get that question a lot. Do you get too cold in space? Do you get too hot in space? Because space can be, maybe either one. We'll get into the details on that, but right when you're sealed up in this, the human is producing a lot of heat, right? Your metabolic rate, and that's what we're fighting. And so we got you hooked up to sometimes it's going down to 30, 40 degrees of Fahrenheit of water to keep your body cool. And then there's adjustability as well. Like on this one, it's a kind of a demo on the front. There's a little knob right here
Right.
to kind of change your AC, if you will, or your cooling on your garment. Is if I'm starting to do a lot of work on the ISS or walking around on the moon, I might need a little bit more cooling. Or if I'm not doing too much, hanging out on the Canada arm or waiting for something to happen, you might turn it down a little bit.
Yeah.
So you have some adjustability, but it's almost always primarily cooling the human. There are some heaters, and we can talk about in the future why you might want more or less heaters. But the gloves also have heaters in them, and the tips of the fingers, just in case those get a little cold.
Gotcha. Hey, here's a good question from chat from RC Horseman. What fluid is in the cooling suit? Is it just like regular water? Is it something with like antifreeze like your car has in it?
Yeah, no, it's just water, right? You have to think of any kind of contingency case if that were to leak inside of your spacesuit. I probably don't want Freon next to my skin,
right?
Or in vapor in my suit. So yeah, it's just water. Now it is really, really clean water. They'll iodize this or put it through a lot of filters on the space station. I think on the space station, there's water for the spacesuits, and then there's water for everyone else. It's very specific. We get very particular, especially once you go into the backpack of the spacesuit. All those parts are very sensitive, obviously.
The special spacesuit water. It's like, no, you can't drink that. You have to save that for the spacesuits. It's got to be super purified. Like it can't have minerals in it that might build up in the valves or something like that, I guess. Is it just like ultra distilled water or something?
Yeah, it's ultra pure. So yeah, we can talk about how backpacks actually provide that cooling. It's either sublimating the water away or evaporating the water away. So as that happens, if you're left with any trace contaminants, those will be building up, right? So that does happen with iodine. There is iodine in the water to make sure it's really, really clean to help fight against any biologics that
could sterilized.
Exactly. So you can get some iodine that could kind of precipitate afterwards, but for the most part, it's just really pure water.
Huh.
And water's actually really good. If you look at like the latent heat vaporization of water,
right?
Even if I wanted to use like a little gel pack for your lunchbox or something, it turns out water's just pretty dang good.
It has some good thermal mass to it. Like if you heat up to heat up water takes an amount of energy more than the air because it's got density, but it's also easy to move around. It's malleable because it's water, a fluid, right? Versus a block of steel or something, right? It has so many different properties that make it good for this. I hadn't even thought of that. Like I thought it was a water cooled suit. I never thought, what exactly is in the suit, but it makes perfect sense. You have a little leak or something, and that gets into the spacesuit while you're doing an 8-hour EVA. It's going to get potentially in your eyes, in your mouth, in your ear or something like that. And you don't want any sort of harmful chemical in there because then all of a sudden, oh gosh, there's a little leak. Now it's in my face, right? I had not thought about that, and I actually put on the cooling garment and got in the suit.
Yeah, that'll happen. And we provide, an additional water, like a reservoir of water inside the suit so you can stay hydrated. They used to do, I think, like a little snack bar or other nutrients. And when you're in microgravity, if you get crumbs in your suit, that's also not ideal. Those are kind of floating around. You don't really want those. So in the current spacesuit on the space station, you just get water. In the future, in the Artemis stuff, you might get a little bit of nutritional
gel
slurry. I'm not sure what it is yet, but it's still a lot of work. If you can imagine, you eat breakfast, you go work all day, you haven't eaten anything, right? So and you're exerting some energy. So
that makes good sense. It's the same as the spacecraft. We've all heard the story, right, Alicia? We've done this many times. The corned beef sandwich in the spacecraft.
Gemini, that's right.
Yeah, Gemini smuggled aboard a corned beef sandwich, and then it caused this huge thing like, oh, the astronaut's not following procedures. Like, big deal. It's a corned beef sandwich. Who cares? Well, a breadcrumb floating around inside your spacecraft can get in your eye, can get in electronics, whatever. Same thing. The spacesuit is your little mini personal spacecraft. And if you have crumbs from who's ever had one of those, like the protein bar, like granola bar that like falls apart whenever you take a bite of it and all the little pieces fall out. If that's in the spacesuit, like you take a bite of it and then crumbs are floating around, they're going to get in your eyes. You're going to breathe them in and start coughing or whatever. You don't want that. So the best you can go, Connor. Yeah.
Then you really can't even touch your face, right? once you're in the suit, your arms are in the gloves.
Yep.
Your face is in a whole other bubble. It's not like you can back your arm out and then get into your spacesuit and then touch your face. If you got to itch your nose or if you got hair in your eyes, you should have thought about that before you buttoned it up.
Yep.
Whether it's hair bands or we still use the Snoopy cap on the astronaut or test subject. It looks the same as Apollo. Still make the same one.
Yep.
You got hair bands, sweat bands built into that. And then there's a little piece in the helmet we call the Valsalva. Like you mentioned earlier, you have to kind of constantly keep equalizing your ears, but you can also use that to kind of scratch your nose if you really wanted to, right? But then water is an issue as well. If you get water in your suit, and this has happened before, but in microgravity, the surface tension is actually a big issue. Whereas if you got a crumb in your eye and you tried crying it out, well, your tears wouldn't go anywhere.
Oh,
right? They're not just going to roll down your face because there's no gravity.
No gravity.
They're gonna pool up right here, and so
just like build up in your eyes.
Yeah. So there was one pretty close call on the space station. You're right. You can look that up. I think it's EVA 23 with Luca Parmentano. He came into the airlock with water, I think, all the way around his head, and it was all the way up to his nose. So that got pretty serious. And it wasn't a ton of water, but it's enough water to build up a layer on your face, and especially that kind of the shape of your face and your eyes. It kind of wants to pool up in your eyes and not move. No matter if you shake your head back and forth, maybe you can get a little bit off, but not
I would imagine
all of it.
Sweat too, right? Like if you sweat a lot, so the cooling's important, I guess. But if you you normally would like the sweat would like drip down on your face, but I guess it wouldn't do that. It would just sort of
just start beating it up and just sit in there, right? So yeah, they always say you want to keep ahead of your cooling. You don't want to get to the point where you're sweating, right?
Right. Huh, that's even that like salty sweat getting into your eyes, and then you can't see anything, but you can't rub your eyes or anything. Like you have to think about all that stuff. Yeah, that makes good sense.
You could. There's cases of crew members, getting burning eyes, and you can't do much. And they say, well, try to cry it out for a second, hang out for 10 minutes. If it gets worse, we can go back to the airlock. If
Come
it gets
in.
better, we can continue doing this EVA. So that's a real thing, right?
Yeah, no kidding.
That'll probably be there forever. If you get a burning eye or whatever it is, something in your eye on the moon or Mars or any space station.
Yeah.
It's kind of a bummer.
Yeah, because you really can't you can't pull your arm in and then scratch your face. You can't get your arm out of the suit arm when you're in it. It fits close enough that there's not that much room in it, right? It's comfortable to move around in. It's not that bulky.
If you do that, then the suit is not fit properly.
Yeah,
right. I have heard of someone doing it.
Really?
But that makes me question a couple more things, right? Like, man, how well is that suit fitting? If I was able to scoot over in the torso and then get my arm back.
Pull your arm out, and like that doesn't seem.
That's really impressive, actually. But no, yeah. So you should not be able to do that.
And actually, on that point, though, regarding the fitting of it, obviously you saw they took many measurements. I was expecting it to be sort of this like big bubble around me. I was expecting to just sort of have lots of room to move in it, but it actually does fit you pretty close.
Follows you, yeah.
Which is, again, helpful for movement, too. If you're in zero gravity or microgravity, you don't want to be floating around inside the thing that's floating around, because then you really can't operate and do things. Like you're seeing here, I actually was using tools in this pressurized spacesuit here and doing little activities on this board. And I was able to do it. I think they said the gloves that they gave me were slightly larger than what they should have been for my hand size, but I was still able to operate it. And there's, we always say like the tools are also kind of specially made, understanding that as well, that you've got sausage fingers, but I could still do things. I could still definitely do all those little board tasks.
Yeah. I got another question here, and this is probably a big discussion. The question is, do the astronauts have to take their glasses off when they put on the EVA suit? And I think we could expand it a little bit. Can you wear glasses in an EVA suit? I actually don't know the answer to that.
Yeah, good question. So you can wear your glasses in the spacesuit. And so if you see any videos of any astronauts on the ISS, I think they're called like hollow frames. They're super lightweight. It's just the lens itself and the skinniest little arm
goes
around their head. I believe we asked them to wear like croquis So it can't go too far if it does, get lifted off the
like a
off
headband
the
sort of
freaking
thing.
nose. Yeah,
Okay.
the part that would tie it around the back. But you can definitely wear your glasses inside the spacesuit. You still have to worry about fogging. So typically on commercial prescription glasses, you can get anti-fog, anti-glare, anti-scratch, all the above, and those the optometrists for NASA, I'm sure they get all those nice layers on there to make sure that there's not going to be any issues. But as well, there's a couple other objects you can put on the inside of the visor. We call it a Fresnel lens. It's kind of like a little magnifying glass.
Really?
Because you have a certain field of view in any of the different spacesuits, there's certain aspects that you would want to see that might not be super visible. So right on the torso, you have the DCM, or the display and control module, which is basically all the switches, all the screens for your spacesuit. And if it's kind of right below you, so you kind of have to look straight down. So it could be a little Fresnel lens that's kind of pasted on the inside of your helmet bubble to kind of get a better view of those little LCD screens and those kind of things. So there's a couple options.
Everybody, it's not even just that you need glasses or not, but you could put a little magnifier there so everybody can see the screen a little bit better, or not have to crane their neck to see it or something. I hadn't thought about that. That makes perfect sense.
Yeah. And when you're in a normal atmosphere or in space, I'd say it's probably not a huge issue. But when you get in the pool, you actually run into some more issues with the light refracting from the water into the helmet, into the bubble. That's kind of been an issue in the past, right? Is you get a weird distortion, kind of a fishbowl effect, and that's not always optimal, but that's kind of part of training, and they can get through that.
Yeah.
Well, that's a good kind of like segue also, and just to mentioning these suits that they're using on the International Space Station right now for EVAs. Those are the suits that they use in the neutral buoyancy lab as well to train for them. And when we were there, we were talking to some of the people. They were saying that the suits themselves are basically things that have been not declassified. What they say,
derated.
Rated. So they're not necessarily like pristine, ready to go for space. They've been used a while. There's a little bit of wear and tear, but they're still really good. So these are the things that they use in the pools now, or in the pool. And so when we were there, we actually saw them getting kind of suited up and everything going in. They actually have their own suit lab at the Neutral Buoyancy Lab as well, with all of these different interchangeable parts for not the Astro Suit that they have at ILC Dover right now. But this is, of course, the current model that they're using up there. They do have some interchangeable parts, but I believe they said that it's medium, large, and extra large is basically what they have to rotate through.
The torso, yeah, it's correct. We currently make those 3 sizes.
Yeah, so every time they have a different astronaut in there, this is Jasmine Mogbelly, actually, who we saw, who's a New Yorker, hey. When every time they come in the day before, they prep their suit, they know their sizes, they can get it all together for them, and then it's all ready to go. And also, their mesh undergarment thing has, you were mentioning before, having some padding and stuff. They have specific placement for the different pads where they want to put it, where they find that there's a little bit more of like a bump or a pressure or something like that.
Yeah, you can see on this screen, I don't want to cut you off, is on her back, she has a large back pad, right? And because she might be a little bit smaller of a frame to fit in the medium-sized hut, you want to fill in that extra void. So you'll see on that one, she's got a lot of a back pad, and I can see some other ones next to that little blue connector. Looks like some on the torso as well, and I imagine there's some on the feet, and the ankles or knees possibly. And usually you have them on like your elbows, a couple places.
Yeah, little pressure points or rubbing points or whatever, friction points.
It's usually a little bit more extreme when you're in the MPL versus like your flight configuration.
Right.
They probably don't fly with those many pads. While the Neutral Buoyancy Lab does a great job to simulate microgravity, the human in the suit is still experiencing gravity, right? So if they're doing different operations where they're maybe at a prone position or an inverted position, you're falling into the suit on your chest or on your back or whatever it is. And so you still have those pressure points. So you want.
And they told us that sometimes they'll actually rotate the piece of the ISS that they're working on so that they aren't, upside down working on something for 10 minutes or something, all the air, the blood rush.
Yeah, there's a limit of how long they can work upside down in an inverted position. Like 5 or 10 minutes before they have to go back to a prone or a vertical position. So So
That
yeah,
makes
the
sense.
NBL
Yeah.
though obviously has a lot of configurability to simulate any side of the space station for just a typical EVA or a very specific EVA that it might train for years.
Yeah. The NBL doesn't have any fancy special technology that makes gravity go away. They have mechanisms that they can use to cancel out the gravity for the suit or the piece of equipment you're moving or whatever. But it doesn't mean that like gravity ceases to exist inside of the suit. If you cry in the NBL, your tears will still run down. Versus if you cry in space, the tears are just going to like stick to your eye because hydrogen bonding or whatever.
Yeah.
So there's so many good questions coming in here. I know I'm jumping in with a lot of questions,
Wait,
but
just really quickly though, I just want to
sure.
point out too, one of the other questions that I had about using the suits in the NBL was, do you put some sort of like a water protectant on the material or something, or is there some sort of like, is it different materials because it's going in the chlorine or whatever? And they said no, this is the actual suits, because if you think about it, it needs to be okay in space, so it's obviously going to be watertight. It's obviously going to be, hopefully not asteroid, but tiny little particle proof.
Asteroid tight.
It's not asteroid proof though.
What?
Micrometeorite, yeah, we
But
protect against those. But yeah, I mean, this is it's like space grade fabrics, right? So they're meant to go to space. They're meant to handle, atomic oxygen. That's pretty corrosive. Nothing really likes that very much.
Yeah.
Solar UV, and then chlorine, right? Yeah, we don't like chlorine. It could corrode some of the metal parts and stuff. But yeah, no, that's a would have been a class 1 flight hardware that you're seeing there. It probably lived out its whole life, its useful life, as we call it, either on the ISS or in class 1s and vacuum chambers, and then it would have been downgraded at the end of its life, to a class 3 or a class 3 water, and then they can use them in the NBL. Now, anything that goes in the NBL will never fly again.
Will never fly again.
Yeah. But they could use that suit until the stitches fall the way out of it, until the fabric is basically non-existent. But yeah, we have to make training suits eventually, but it's just flight hardware that we downgrade to that condition.
Yeah, it's not like a special NBL only suit versus a suit that can go to space. It's, well, the suit can go to space. Let's put it in the NBL as well. I want to talk about the micrometeorites a little bit, because we see these images and it's like, here's what a micrometeorite moving 80 bazillion kilometers per hour does to a piece of aluminum, right? You've seen that. But how could you possibly make a spacesuit not micrometeorite proof? How does it deal with that? Does it have like a self-sealing fabric, or just what does the spacesuit do to help with micrometeorites?
Yeah, so on the outside layer, when you see like the white on that suit, we call it the TMG, and it's for thermals and micrometeorite garment. That's T, M, and G right there. So just like the space station has like what we call the Whipple shield.
Yeah.
It's a thin piece of metal, a kind of a gap, another thin piece of metal, and then maybe the pressure hull of your spacecraft. We do a very similar thing. That material is made out of Nomex, Teflon, Kevlar. So it does that very first Whipple shield effect. It'll break up the particle, whether it's hitting it. And then there's a bunch of mylar through there, and that's a lot of the thermal effects. But then you have a kind of a soft layer of like a neoprene coated fabric. And that's what really soaks up all the rest of the energy of that micrometeorite. So same thing. The first impact is going to break it up into a finer, projectile, and then it'll get absorbed into that last layer. And that's all before it gets to the
pressure
structural layer, and then behind that is your kind of your pressure retaining layer. So you got lots of layers, and
y'all. So I mean, you're in the suit room right now, but right next to the suit room, there's like a prototype fabric sewing room, isn't there?
Yeah. Here in Houston, so we're called ILC Dover. It's based in Dover, Delaware, right? So our manufacturing facility and all the great folks up there are actually the ones producing Class 1 flight gear, and have been doing so since Apollo, like we mentioned earlier. And that's really where all the magic happens. But down here in Houston, we're here next to the customer, so we can provide a lot of support for mission support. So we're there on EVAs and mission control. We're there for Class 1 fit checks. We occasionally go to the NBL if we're doing something special. But then we do a lot of prototyping. This is what Houston is kind of for, is kind of the R&D center for this. So this whole suit was developed down here in conjunction with the folks in Delaware. But we also have a large sewing room next to me a big cutting room, a big heat sealing room as well.
If I'm overstepping my bounds, please let me know. But can we see the sewing machine?
Ooh, let's
Is
do
that a
it.
thing?
Yeah.
Can we do that?
Yeah, let's go for it.
All right, bear with us. I think we're going to try to move the laptop here, so the signal might hiccup. But let's see if we can go to the prototype sewing room real quick. We checked this out. Connor's just literally going to stand up and walk into the
Going
other
down the
room,
hall.
go down the hall, past the ceiling room there, and I think this is the sewing room, isn't it?
Yeah. So this is from one of our areas of the lab that we have a lot more. Sorry, bear with me for a second.
No, you're good.
A lot more stuff in here. So kind of what we've been using the whole time, right? We're sewing stuff. I got a classic Singer right here. It is industrial grade, right? It's got a big motor on the bottom and it's belt driven on the outside. So a little bit beefier than what you might find at your grandma's house. But it's a thread and needle at the end of the day, right? So
yeah.
So we still have full capabilities to manufacture soft goods in this environment, and at the same kind of pedigree as you would see for flight.
So this blew my mind when, again, when they were so gracious as to invite us, into their facility here. They took us through this room, this sewing room, and I just my mind was blown. I'm like, these are literally just sewing machines. This is incredible. And that one in particular, that's not a plant. That was there when we were there, and I was like, this is from like the 60s or the 70s. This is wild, maybe even older. I don't even know. But it really is interesting. And yeah, so this picture is actually, I took this picture while we were there. This was kind of some of the layers. This is all the layers, right, of the spacesuit. So many different ones, as he said. It kind of breaks it up as it gets through it further, and then of course you've got that bladder at the back.
Do you have?
Yeah, Connor, I think you have one there.
Do you have that there?
Yeah, I actually have that big one that we have that you're showing right there.
Yeah, that's stuff.
Yeah, so like I said, we have lots of layers, and you might think it's once it's all stacked up, it's pretty thin, and it does get pretty thin.
Yeah.
It's all still fabric, but everything has this very specific purpose, right? And that's anything with in the spaceflight community, right? It's designed for certain requirements. Whether you're going to the moon or the space station or just to orbit, you could have a different set of requirements, which would then have a different stack up inside of here. So we were talking about earlier that the outside layer, the TMG, is that thermal micrometeoroid garment. Like I said, it's made of Nomex, Teflon, Kevlar. You can see kind of the Kevlar.
It looks like ripstop. Yeah,
exactly. So just like any ripstop nylon, that's that Kevlar in there. A lot of that mylar below that, all the silver layers. So if you ever see a satellite or see the Apollo lunar lander with all that kind of gold foil on it, if you will.
Yeah.
Same deal, right? It's a aluminized mylar. Those could have been a aluminized Kapton as well. You probably have some ripstop on there as well, just because these get pretty thin.
Yeah.
A bunch of layers for that. If you're going to the moon on the South Pole, you might want a couple extra layers of this on there, maybe on your boots and your legs.
It's like insulation, right?
Extra insulation.
Extra insulation.
Right? We're keeping the heat in and keeping the radiation out. So we talked about that first layer is really what's going to break up that micrometeorite. All your thermal layers in here. It's going to keep you nice and warm. And then that neoprene kind of coated, right? Oh. This is what's really going to catch all the rest of that energy from any micrometeorite. And after that, and you can see, if you ever see a spacesuit without its TMG on, it's kind of like you're looking at it's kind of naked after that.
Right.
Right. So you kind of have what we call the restraint layer. Could be really strong polyester or Dacron or Spectra. Right. These are just really, really strong fabrics. But this layer right here in particular is what gives the structure of the entirety of the spacesuit. So just right behind me in these little gloves, that's what you're kind of seeing. This is the naked bits, if you will, the very interior of the glove. And then below that is, this doesn't hold air, but it just holds the pressure. Is this kind of yellow layer on this one is a urethane coated fabric. So that's really what the pressure retaining layer is. You could have it single coated, double coated, depends on where you need it. And then that's really what you're holding on the spacesuit. Everything after this is what you were kind of wearing, like Alicia was showing earlier, that cooling garment. And I have a couple tubes kind of embedded in this one as well.
Nice.
Get that's kind of blown out a little bit.
Yeah, it's okay.
But yeah, and that's that kind of stretchy spandex kind of layer in there as well.
Yeah. It's real quick, Connor. You said one part is the structure that holds. I want to say it the right way. One part sort of holds the mechanical pressure or the mechanical forces,
Yep.
and the other one holds the air pressure. Tell us the difference between that, Rick. What's the difference between the mechanical force and the air pressure?
Yeah, so if you've taken any, mechanical engineering courses or civil engineering, or not at all, but I have to react to that load somewhere, whether it's your hoop stress, your longitudinal stress, right? So if I inflate a balloon, it wants to get not all, a balloon maybe is a bad example, but it wants to get wider and it wants to get taller, right?
Yeah.
So I have to counteract that somehow. So your hoop stress is what's going to make it get a little bit wider, or circumferentially around an object.
Right.
I had to maintain that. That hoop stress is not too high. It's their longitudinal loads are a little bit higher that you might want more reinforcements for. So not only is the mag glove trying to get wider on every single spot, it's actually also trying to get longer.
Mm-hmm.
So you have different axial webbings that would run the length of your arms that really hold that load on there. So without thinking about whether it's air or water pressure, hydraulic or pneumatic, you have, like I said, you have to maintain that structure. So the similar structure as any spacecraft or a space station module, you see that that ortho grid or that iso grid looking structure.
Yeah.
That's what that layer is, right? That's maintaining everything. Now, like I said, it's not. It still can breathe. Air doesn't get trapped by that layer. So that means I have to trap the air with some other layer. So you could use an analogy like a bike tire. Inner tube to your tire. This yellow is the inner tube.
Right.
And yes, it can hold the air, and you could, I don't know, you might not want to do it. You could probably ride your bike on just inner tubes.
On just inner tubes.
It might look a little funky. They'll probably get squished out, right? But that's the same kind of idea. This really holds the air in, but this will just be a balloon.
Right.
This will just expand, and then not do anything useful with it. So this is what we're retaining that layer, or we call it the restraint layer.
Restraint. So it's almost the bicycle inner tube is almost the best example because you have the tough outer part that actually holds your bike up, right? That keeps thorns from going through the inner tube. That's the tire on the outside, and you have the tube inside of it that actually holds the pressure. Some modern bikes don't use inner tubes like that anymore, car tires, whatever. But it's almost like, think of a balloon that you put inside of a bag or a mesh bag or something, and you could blow the balloon up, but then it's eventually going to fill the bag, and then the bag will keep it from getting even bigger, right? The balloon won't like go out of control and overinflate or stretch beyond what it should be because you have this restraining layer, this other thing that's not capturing the air, but it's keeping the balloon that's holding the air from getting too big or getting out of shape. Does that make sense to anybody?
Makes sense, yeah.
Chad,
That's a good analogy. Yeah, like I said, that's really what's keeping the structure together, right? And it kind of sounds funky. It's like we're just relying on fabrics, but when you have hundreds of pounds per square inch of tensile strength, you can really hold back a lot of pressure, right? And this goes all the way through not only to spacesuits that ILC Dover makes, but we also make space inflatable habitats. So you might have seen recently different videos or photos of those burst tests. I think ILC Dover was partnering with Sierra Space on that. You probably see it on their social medias. Those life habitats, those are actually manufactured at our facility. It's the same thing. Now, as you get bigger and bigger diameters, those loads get higher and higher. Now, the pressure might not increase. It still might maintain an atmospheric pressure of 14.7 psi.
Right.
But the bigger diameter, I had to hold a lot more stress now. And that's the name of the game is, what do I do with that stress?
You don't want that suit to pop.
You don't want your suit to pop. However,
pop like the habitats.
If you look at those videos of those habitats, those webbings on those are pretty dang thick, right? I probably wouldn't have the dexterity in my hands if my gloves were made of webbings that large, right?
Right.
So it's all a trade of where do I put the strongest material? Where do I put the thinnest material? How can I maintain my dexterity, my mobility, while all maintaining an appropriate factor of safety? And that's the name of the game. Obviously, we're going to be safe, and to meet all the NASA standards, you have to have certain redundancy, whether it's secondary restraints, tertiary restraints, whatever it may be, is you can never have, well, not always, but you really don't want to have a single point failure on any mechanism, whether it's a computer for space, whether it's a spacesuit or a spacecraft. That's why all these spacecrafts and things have redundant engines, redundant valves, redundant, whatever they are. Same thing with a spacesuit. We got redundant restraints or different axial webbings. I can maybe show you on the other one is like on the arms and legs. There's always two sets of webbings that are holding it together. Like I said, that longitudinal load, that lengthening load, is pretty high. I have two sets at all times, right? And that's part of the checks and balances that you do when you rebuild the suit and make sure it's fit for use. Is the primary looking good? How's the secondary look? It doesn't have any tension on it? Perfect. It shouldn't, right? It's only meant for an emergency, right? Stuff like that.
Like the primary has failed or stretched or whatever, and so then the secondary takes up the load, but normally the secondary is not taking any load, I guess, question mark, right? Oh, hey.
It shouldn't be. Yeah, exactly.
Well, that was taking some load.
There's a good video of the burst test, right? Those webbings are pretty dang thick, right? I've been able to see them up close. That was a subscale burst test that we did. We've done a couple of them. That actually might be a full scale. We've done a couple of small scale, full scale, and it's all about where the market's shifting on space stations in the future. So commercial space stations, you might be able to see one of these kind of inflatable style structures.
Yeah, I think that one was looking at the video title, it was the full scale inflatable habitat burst pressure test. I have a question. I don't know if you're allowed to answer, but just blink twice if you can't. Have you ever popped a spacesuit like that intentionally?
Me personally, I've not.
Okay, you personally.
but yeah, so when you develop, so we can talk about the Astro Suit, right? That's part of that structural verification. We have to prove that not only do we design it on CAD to meet these certain loads, but then it actually meets those loads in real life. So usually what you'll do, I think back in the day, you'd probably just pressurize it with air until it pops.
No kidding.
Kind of as plain as that, and we'll measure it. That's a little bit energetic when you have that much air in there. So we could do also a hydro burst test. As we normally see is water is incompressible. It's a little bit easier to apply pressure, and then you can just get a little bit. It's not as drastic of a failure once those pop. So the torso of that Astro Suit, I've seen. I wasn't personally there, but they put it in the little shower, filled it with water, pressurized it, and said, "All right, let's just go for it." Right, and they can do that with just the bladder layer. Say, yeah, that meets all the safety loads without even the restraint layer. Add the restraint layer, pressurize that one. Okay, leaks here or there if you overpressurize it on a joint, but that could just be a retighten that screw or something, and it's just fine. And then you could go all the way to popping. Do a burst test.
I think a fun day at the office, just blow stuff off. Like, what's it gonna take? Let's go.
We're here to overpressurize some spacesuits today. I think I understand why we don't see those tests on social media. Like a inflatable habitat test to failure is one thing. A spacesuit test to failure, I don't think the spacesuit would fail in such a dramatic fashion. It'd probably start to leak before anything else, right? But I guess I understand why we don't see an exploding spacesuit on social media, right?
Yeah, exactly. But just like anybody in the spaceflight industry, when you're trying to qualify a unit to be certified for flight, you would have gone through all those tests,
right?
Burst tests. You go through different vibe environments, thermal, vacuum chamber tests. I think one of the more exciting ones was when we tried to blow up the helmet bubble, or pop it, if you will.
Yeah.
Those things are so strong. I think we broke our GSE, or the equipment that's holding it together in a little cage. The cage kept breaking. We couldn't
really.
It was, I forget the numbers. It was just like an absurd amount of pressure. Where it's
that's assuring though. That's very reassuring, because if you're in it, you don't want your visor, you don't want your helmet to break. Like that's your face, right?
Yeah, you don't want it to shatter. And again, same thing with redundancy, right? We talked about there's multiple layers on the helmet itself. There's an inner pressure layer. There's a visor in the new suit. There's visors in between the layers.
Yeah,
keep out of the dust, keep out of getting scratched, stuff like that. Then there's an outside layer that can provide all of them, or not the thermal and visor, but it's another pressure layer. So again, everything. These are designed and built for NASA, but anybody in the commercial industry can purchase these. They're up to NASA standards. Everything's redundant, everything is safe, and I mean, you could take a baseball bat to these helmets. You'd get tired before anything else would happen. And it's actually pretty incredible. I've seen a suit that's older than myself go through a full gamut of tests. And even that's a great segue to those suits. Some of those could be 10, 15 years old.
Yeah.
And it's like, I don't even have any pants that are that old. Like nevertheless, a garment that's going to keep me safe, operational, and complete the mission.
In space, yeah. Here's a quick question. In The Martian, we're going there. Could Mark Watney have taped his spacesuit visor in pressure sealed? Is that realistic, or is that like totally made up movie nonsense?
I think in the movie they did that, and if you read the book, he goes even further. Yeah, taping his suit together. Now there are some pretty strong glues that you could use in the spacesuit. The spacesuit does have glue in it, and it's right, funny, but it does. Could you maintain a pressure? I think so. He had a special backpack, right? He had a tank of nitrogen and a tank of oxygen. He had a lot of air,
right?
A lot of room to go through. So it's all about your leak rate. I probably wouldn't get it to 0, but I probably could get it low enough to run back to the hab or whatever he ran back to the another helmet, and then he went back to his rover, right? I wouldn't say no, but it'd be pretty extreme. On the go while you're leaking.
Speaking of Mars, though, these materials that you all have developed, they're rated for the moon, right? So the moon is obviously worse than Mars, I would assume, with radiation. You're closer, and there's not really an atmosphere, to scatter some of that like you have on Mars, even though it's light and small. So if we were to actually, which brings me to another point about this suit, by the way, which we haven't even touched on, the fact that this Astro suit is not only an EVA suit. It doesn't just, it's not just for spacewalks. You can also use it for planetary exploration as well. You can literally go in space and then also set boots on the ground. So let's say you were to take a suit like this, to Mars. Do you think that you would just use the same materials, or would you maybe kind of come up with a new type of material? I read somewhere a while ago that the Perseverance rover actually carried with it a few samples of different spacesuit fabrics and like helmet materials that they were going to study to look at the change over time. There's like a camera or some sort of instrument studying these materials on Percy right now on Mars, and that they're looking at the Martian environment, just the dust and everything like that, to see how it holds up. Is that something that you guys are working with as well, to see like the degradation and just thinking about, again, planetary exploration, the material that you guys use for the Astro Suit, for example, is that good for all environments or just the moon right now?
Yeah, so I'd say probably one of the harsher ones is probably the UV environment. Being in low Earth atmosphere, you have no Earth's atmosphere low Earth orbit. You have no atmosphere to kind of help protect against the UV radiation. That's probably one of the most degrading elements out there. I'd say on the moon or Mars, you get a lot of dust issues, right? And even that's not like the end of it all. I think it's not too complicated. I think there are solutions out there to help with dust mitigation. I think the worst part is like the moon gets those are pretty sharp silica style
granules, grains,
yep. And so so you can get a lot of abrasion. But I think we've done in the past. We took a whole bottle of like regolith simulant and then just poured it right into the glove, and then just did its full life cycle operating it. And it wasn't like too crazy bad. I don't want to pour lunar regolith in my glove, but if I had some dust in there, it's not going to be the end of the day immediately, right? So but that's just kind of what again, we kind of talk about the design requirements is how long do you want your spacesuit to operate? How much maintenance do you want to be able to perform on it? What does your logistics look like? How many rockets do I have going up and coming down? Can I have a nice rotation of suits constantly? No suits over than 5 years old. You just keep rotating them out, right?
Right.
Stuff like that. The backpack could last a while, but maybe the soft goods you might want to switch out a little bit more frequently. A lot of our stuff's rated for like at least 10 years, which is quite a long time. That's 10 years on the ISS.
Yep.
For long duration missions. Because mass is something, right? Up mass and down mass does cost money to get that up. Obviously, we're seeing the state of the industry start to shift, where the mass to orbit is decreasing, and then after that, it won't be as big of a deal. But I guess kind of going back to, is it rated, and what are we looking at for research in Mars? We constantly work with universities, NASA, different industry partners of what would be the best materials. We have our material experts, going to, there's kind of like trade shows for textiles, for the most advanced textiles. So, we're constantly out there. We have great relationships with these vendors, and folks that are actually, have like the manufacturing facility to weave these materials up. And so I'd say it's not like an impossible solution, but it's something that has to just be designed with those requirements in mind.
And Connor, real quick, let's let you go back to the other room with the spacesuit real quick, and I'll talk while you're walking. It almost sounds like it's more of a customization sort of thing. Like a lot of the parts of the suit stay the same, whether you're doing an EVA at the ISS, or you're doing on the moon, or you're on Mars, or whatever, right? But if you're on the south pole of the moon, maybe you want to add another radiation shield, right? And you just add another layer into that design. And if you're on Mars, maybe you add another outer layer, you add extra gussets to keep the dust from getting in or whatever. It sounds like most of the parts of the suit stay the same, and you just make tweaks to it. You don't design a fully new suit just for Mars, right? Am I understanding that correctly?
Yeah, that's pretty much spot on. I'd say like the structure of the suit is pretty well developed. It's pretty mature at this point. Obviously, we have flight heritage that's already flying. So we have that expertise as well. But then it's just a different design requirement, like we were saying, is if I want a little bit more dust protection, a little bit more radiation protection, it's kind of this cover layer. You see right here is I can put, like you see like on the elbows, it has a little bit of extra material on the elbows to help with if you were on your hands and knees, I guess, and had that extra abrasion on your elbows. I think the knees also have something very similar. So it's really that outside layers. You can kind of customize it per your mission.
Yeah.
So that's actually a great kind of segue to, I think, maybe talk about some of the underwater stuff too now. So there really is kind of this fascinating link between like deep sea diving suits. You've seen the old, the metal helmets with the great thing in front and everything. Obviously, they don't use that anymore. But this idea of like underwater engineering, I'd imagine that you're working with things like extreme pressure down there and fluid dynamics and leaks and stressing the material, all these things that we've just talked about already. Like I mentioned earlier, in a past life, you used to work for Oceaneering. You did a lot of underwater engineering work. Could you talk about some of the overlaps? And I mean, I'm also curious, what led you to shift from underwater work to aerospace and suit design? And how has that background helped you maybe in unique ways? Maybe you notice things that other people don't or something.
Yeah. So I guess I'll start with that first part is, it's kind of, I always kind of think about it as kind of like equal and opposite. Like, I know it's not exact, but it's like, if I want to go to the bottom of the ocean or, deep underwater or into space, I have to maintain a livable pressure or an operational pressure inside of my suit. So now it's when you're going deep sea, I have a lot of obviously a more external pressure pushing into my suit. So I want to make sure it's strong in that regards. And then obviously when I'm in space, I have my pressure is on the inside of the suit, trying to expand it outwards. So in that regard, I always would kind of compare it to equal and opposite. But no, I went to an engineering A&M University, which is they have a campus down here in Galveston, which is known for its I'd say marine degrees. And so ocean engineering was the hardest degree at the time, and I said, well, that's the one I want to do. And so then a couple years into it, I saw some of my buddies that also graduated with the same degree go into the aerospace industry, and I said, holy cow, that's awesome. We live here in Houston. We're kind of in the proximity of, if you want to do engineering and you want to do hard engineering, I said, man, that's what I want to do. I don't want to do this easy stuff. Let's do the hard stuff, right? So I kind of just knew going into it that I kind of, a couple years into my schooling, I was like, man, I kind of want to be in the aerospace side instead of the ocean side. But then I looked at my transcripts, my curriculum. I said, well, if I change now, I have to spend another 2 years in university, and I kind of want to get out there into the real world. I did look at getting a master's degree, and I got into an aerospace program at A&M University, and decided, hey, I'm going to go get that job instead. Let's get some more experience and stuff. And so I'm really glad I did. I was able to land a really great opportunity at Oceaneering and work on their offshore projects group over there, where I got to do, like you said, some of this underwater stuff. I'd say the biggest thing that I noticed is everything is huge in the oil and gas industry, right? If you're going to the bottom of the ocean, your wall thicknesses of your pipes, these manifolds, these valves, this stuff is just ginormous. It's just crazy. So I was able to work with that stuff for a while. Had a great opportunity going offshore on a couple projects for different big oil and gas companies. And I got to be able to do SIMOPS with diving in the water, along with the ROVs that are remotely operated, little robots, to do construction. And so it was really a great opportunity to kind of see, you got helmet cameras on the divers, you got cameras on the ROVs. These guys are working together to accomplish whatever the mission would be. And so I kind of saw there and I said, holy cow, I have this opportunity to go do that same thing for space, sit there and help behind the scenes, obviously, but in mission control and monitor these missions, right?
Yeah.
So I don't know, I just kind of got into it and knew, I was like, man, that's some really, really cool stuff. But I had to thank some really good friends of mine that kind of got me into it. I know, Clark Room, a great friend of mine, showed me the path. I was like, man, this is a real life thing. So I think just being in proximity with the NASA and just knowing what you want and just going for it, right? I think that was my big motto in school, is having that drive. I think is super important. I think everyone that's in this company and here at ILC Dover, and I see it all over the place, no matter what space company you are, man, if you're in the space industry, you're there because you love it. You might be working 80 hours a week and busting it, but you also might have a really chill job. You might not do too much, but man, all these people here, whether it's at NASA, any of these industry partners, man, it just seems like everyone's here because they freaking love it,
Yeah.
I do have to say, like, everyone that we've ever spoken to doing anything, any career in the space industry, it's just so fascinating to hear how they got into it. It's just like the different backgrounds that people come from. I love that you have this undersea engineering thing. Like, was that a wild learning curve for you to jump from, thinking like inward pressure versus outward pressure? Like, did you have to kind of unlearn and recalibrate your brain to just like think of, and also just the idea that everything, like you said, was so big, and now you're dealing with these like tiny little stitches and these very thin materials. Like, you're on a macro scale even now.
Yeah, that's probably the biggest one, right? Is your weight savings. Is like, when I have to pack this on a rocket and fly it to space, every gram and every ounce matters. Whereas if I'm going to subsea, you want those factors of safety, and you probably want them a little bit higher. Those are going to be down there, have a lot of corrosive environments, and at the bottom of the ocean. But yeah, so that was kind of probably the biggest change is seeing how kind of small and precise these things can get. I mean, we're looking at spacesuits. We're talking about those. They're made on sewing machines. I mean, they're still handmade. I mean, it's utterly impressive how precise these garments can be made. Every single stitch is precisely placed, and so I can't give enough praise to the folks in Delaware that make this happen. It's like a miracle. It's kind of like black magic. I just get to be able to see it down here and get to see it in use. But those folks up there are really, they're making the sewing machine work. They're making it to making the bladders, the sewing machine, the garments. It's really, really impressive stuff. And like we said, talked about your factors of safety or the precision that this stuff is made with. Yes, the oil and gas company industry has a lot of requirements. I think we've had a great, in the last 10 years, a couple good examples of, things going not so well. In the Gulf, we had a couple oil spills. In California, had a couple oil spills on the West Coast. Those are big learning opportunities. Obviously, those happen all over any industry. That's just kind of the precision that's required, right? Is you can't failure is not acceptable, and then you throw the human into this, and then it's really not acceptable. So it's the human space flight. Obviously, the NASA is safety first, and that's what everyone breathes here. Is even if you're all ready to put someone in the suit, you're all buttoned up, you still have that last safety briefing, right? Is here's XYZ, here all the opportunities. If a fire alarm goes off, the power goes off. Here's what we're going to do, right? And I know we walked through that with you as well, right? Is okay. We're going to have fun here. We're going to have a good time, but here's the seriousness right now, right?
Yeah, yeah. Hey,
that happened too, didn't you? Like a fire alarm went off and somebody was in the suit, and they just kind of walked outside the building too for you guys too, for your building.
I remember that.
Yeah. We always have. I mean, it's NASA, right? So we have these contingency plans.
But I said that was a contingency plan. Yeah.
And you got to back up to that plan, right? So,
hey, here's another good question, and this is a little bit of a serious thing, but we see the sewing machine. Right. And you talk about they're still hand sewn. What's driving that? Is it just that there's so few suits, it still makes sense to hand make them? One day, if there's 1,000 EVA suits needed for a lunar colony, does it get into like CNS, computer numeric sewing, or some computer robotic arm doing the sewing or something like that? I guess the question is, why are humans still doing it? Is it just a factor of scale? What happens if you need to make 1,000 spacesuits?
yeah, that's a really good question. I don't know if I have the exact answer for that, but yeah, I think scale could be a little bit of it as well. But I think just the precision required to be able to manipulate. I mean, it's not just I'm just having a piece of fabric and it's just sitting here flat, and then I rip a long 12-inch seam unit straight. Now, something like that might be a little bit easier, but it's all these intricacies. And we talk about tolerances. We talk about for safety or for when you manufacture something. The tolerances that you have on these items, some of them are incredible. So we talk about like the gloves, and I use that as a good example. Is you want the most dexterity in your glove, so you want the least amount of excess fabric. So whether it's on your shirt that you're wearing or whatever, if you look at your seams, there's a lot of overlap on the inside, right? Well, I don't always want that overlap, especially in between all my fingers. That might inhibit me doing my job proficiently. And so I think some of the seams are like a 32nd of an inch precision, which is now, and on a scale of other things, it might not be too much, but when you're hand sewing something, I mean, it's hard to get within a 32nd of an inch on something.
Yeah.
So having that kind of detail-oriented design where you're able to implement something that's that precise, I think it's just going to be in the hand being hand done realm. If that makes sense. So it could be a little bit of scale as well, but it's just like it's just one of those arts.
I think art is like right there, and this is I dabble. I have like a benchtop CNC that I can afford, so it's not insanely expensive. But the CNC is so it just assumes the material is where you said it is going to be. Right? In the work holding and keeping things in a very specific position. You get into the big expensive CNCs and they're flipping things around, but the stuff has to be held very, very precisely in order to accomplish the precise work that you're doing to it. But with a fabric, the way the fabric sort of moves and you hold it and you can scrunch it, fabric isn't a piece of aluminum or titanium or stainless steel or whatever that you can really fix into a work holding fixture, I guess is the way to say it. I can see how where we are right now, we'll get there one day and computers will be scanning it and they'll know where everything is, even if it's fabric or whatever. Right now, the way we do the work holding, I could see the human hand still being the way to feel that, to know that it is where you want it and it's scrunched the way it needs to be or whatever. We'll get there one day. I'm sure there'll be robotic arms making spacesuits one day, but still we have the sewing machines like we saw in the other room doing it for now, huh?
Exactly, right. And like you said, it's an art. And these folks are so good at what they do. They can see it, they can feel it.
You can feel it, yeah.
Yeah, and I've even shown, and I've been trained a little bit on how to sew, and just like really simple things, like, and I'm just like, you have to monitor every single stitch with both layers, or if it's multiple layers of fabric, they have to all line up. Like you said, the conformal aspect of it being a fabric makes it that much harder, I think, to manufacture versus a CNC block. Now, there's a lot of precision that's involved in those things, obviously, and it's you pay money for those really expensive machines to be precise. That's why spacesuits aren't super cheap. Is you're paying for that precision and that's being handmade.
Yeah. I get it. I think I'm positive one day we'll get to a point where there are factories making. I hope we do. I hope we have a colony on the moon, and we need 1,000 EVA suits to be made. And I sure there'll be a big robotic factory cranking these things out. But for now, I think the scale of them, the quantities that get made, it's still an art versus a. It's an art and a science. I don't want to say making a spacesuit isn't a science. Clearly, it is as well. But the fabric, putting the fabric together with the stitches, is an art. I have a couple sort of show big questions here since we are almost out of time. Connor, I think we could talk to you for like 3 or 4 hours. We need to do an entire show that's just like spacesuit movie critics, where we look at things that have happened in movies and you tell us if it's legit or not. Like we could do an entire show like that. But here's a big question. How far are we from the sci-fi form-fitting spacesuits, right? The spacesuits in sci-fi, they're so tight and they're so thin, and it looks like, oh, they're so maneuverable because they're not bulky at all. How far away are we from stuff like that, or do we even need stuff? Will we ever go there? What do you think?
Yeah, good question. I think it kind of comes down to a few factors, and the first one I'll say is again, it's like a broken record, is your design requirements. Is when I pay a vendor to deliver a product,
right?
I'm expecting something. So these suits right here behind me are designed to be modular. You can change out the lower leg, you can change out the arm, you can change out the glove, and then every one of those parts has a range of sizes that you could go through. But it's meant to be from the 1st to 99th percentile of adult humans. And so that's a pretty huge range of folks. So that means if I'm really, really skinny or I'm really, really big, I still fit in the same spacesuit. So the really, really skinny person, yes, we can adjust it to make it as form-fitting as possible, but you might have some extra room, which again, we talk about those pads you can put
like
on
a pillow in there with them. Yeah,
to kind of fill some of that void in. But this one does it really, really well. Whereas I want y'all to look at, if you can look at the A7L, right? So the Apollo spacesuit that went to the moon, ILC Dover manufactured that suit back in the day. If you can find a photo of it without the cover layer, you'll be surprised actually how slim fitting it is.
Yeah.
So you'll see like a whole blue layer. That's like the restraint layer. You'll see some zippers, some stuff on the shoulders, your arms, your legs. The funny thing about that is those were handmade for each individual person. Neil Armstrong had his own suit, custom tailored just for him, right?
Yeah.
Alan Shepard, everybody had their own suit just made just for them. So you could be super conformal. Now, that works if you're only going to send a couple people to space, and you have the budget or the appropriate money to do so on a custom suit. Now, we start talking about, once we got into the space shuttle era, right, now we went from a couple people per capsule to 7 people on a shuttle at a time.
Right.
So now I need suits for a lot of people. Now, not everybody goes outside and does EVA, but now I have a larger audience of folks that I want to fit into the spacesuit. And now we're upping that game even further with this one. So I do hear that all the time, like, oh, it's big, it's bulky, it's not so small. When are we going to get small ones? It's really how much money do you want to spend, right? If you want your own custom suit where the arm diameter is perfect for you, the waist diameter is perfect for you, and maybe no one else, you could do so. You could do so today, but you got to pay for it, right? So that's the case. And when NASA, one of the biggest customers for spacesuits is buying stuff, they're going towards this commercial kind of aspect, right? Is we're not just doing it just for one individual. There you go. Perfect.
Is that the that's the A7L? That's at the museum in Huntsville, I think.
Yeah. So if you see those things pressurized, it's pretty dang slim. It's actually impressive. And so, but like I said, that's custom made for that one person. The arm, the chest breadth, the shoulder distance. I mean, everything, right? The shoe size. I mean, every single aspect of that is custom made for someone. So it's just a different design requirements right now that we're going to more modular, more adaptable, and be able to, there's some good ones right there. I mean, like that doesn't look any bigger than that human inside of it, right? That looks like very close. So you can do that, and we've shown we can do that. And we also show we can do the most modular suit that's imaginable. And that's kind of the name of the game right now is different countries, different private partners can have a numerous size of astronauts. And we still see that today is we want to be able to fit them all and fit them appropriately. And that's like I said, that's the name of the game is that proper fit. So being able to walk around like this, these videos you see are in 1G with a full flight-like configuration. Obviously, the backpack is a demo backpack just to pressurize the suit. The suit is pressurized right there to operational pressure. This is great.
It's like walking around outside. The golf club? There's a golf club involved. Of course there is.
I mean, we've gone golfing on the moon, right? So we got to practice those skills. That's not too far.
Just part of training.
Yeah, it's just part of the training exercise, right?
That's so funny.
So
I love it.
But yeah, having that form fit and being able to do those things is key, right? Like I said, it's performance. How proficient do I want to be? And what am I doing? What's my mission, right? Walking around on the moon?
Yeah.
That's doable. Sitting, these pants that you see right here, like we talked about earlier, have multiple bearings in the hips and the thighs to be able to walk around like this, be able to use different grabbers, I think we're just picking up random little objects in the grass.
Yeah.
But that's what we're going to be doing, right? Is doing different science, different geology on the moon or Mars. So you got to be able to do those. And then the biggest one that we like to do is we've taken these on ATVs. Different quads. You can sit down on these things. They're
really?
You're meant to be able to sit, stand, walk, strap your feet into the Canada arm on the space station, do any number of those things. That was a sweet transition right there. So now we're going back to baseball, right?
Back to baseball.
This showing, I think one of the other Astro Museum videos also has like some frisbee in there, and it also shows a really good demonstration of mobility. I think right here is a great demonstration of right when you get a proper fit. And that just takes some time, right? There's little tweaks here and there, right? If you already get back in this suit, we might give you a little bit different size gloves, shorten an arm here or there, shorten a leg here and there, add some padding to help fill out those voids if there are any left. But to get this proper fit, and obviously this is one of our engineers in this suit, so they have had a lot of hours.
He knows what he's doing.
So they know how to work it, right? It makes it look a little easier. But this isn't like you have to have tens of hundreds of hours to be able to do something like this. Obviously, Alicia did it.
Alicia hopped right in.
I mean, I did. I had no just absolute disclaimer. Yeah, I had never been in this thing before, and I was able to do it. It wasn't. I couldn't do jumping jacks and push-ups like your colleague that also got in and demonstrated some stuff for us like that.
Right here, like this leaning over, this bending, and then this one's kind of crazy. This bending backwards.
Oh wow,
that's really crazy right there, right?
Behind you, really, that was the struggle for me, and I think I was also being a little precious with it. I didn't want to break it, even though I realistically I could not have broken that thing if I tried. But the other guy, he was doing stuff. Obviously, he was a lot more comfortable with it. He had the hours of practice in it and knew how to move it. It was a little bit like. What did you say? There was like a muscle memory thing you referred to.
Yeah, we call it
programming.
Programming. You're programming your brain. Yeah, but the way that you move your arm because of the rotation of all of those bearings, right? So thinking of to lift your leg, you kind of had to move it out a little bit, rotate it out slightly, and thinking about
that's one of the biggest ones. The astronauts, they do so much training, right? Is to figure out how to work with the suit, how to not to fight the suit. So he's playing some frisbee right here, pretty nonchalantly, right? So it's understanding because, like I said, you're in that suit for 8 hours or 6 to 8 hours. I don't want to be overexerting myself if I don't have to be. I want to be very proficient, and that's the name of the game. Is every movement takes a little bit of force, more than what you're used to without a spacesuit on. So every time you move your arm, every time you move your leg, every time you're walking, you got a little bit more weight on you. You're burning more energy that you would be.
Yep.
You want to be proficient at it.
And not only that, when you're in space, you don't have gravity working against you too. So I would also imagine that you're also exerting more force than you would need to if you were in space.
Yeah.
Yep. You're wearing it.
it's not like power armor, right? Where the suit is moving, the suit doesn't realize you're trying to move your arm and help you move it. When the arm of the suit moves, it's because the muscles in your arm moved it, and the suit didn't get in your way. Like it lets you move your arm that way, but it's still your physical strength that's actually moving the suit around, right?
Mhm.
It does hold itself up a little bit. So when it's fully pressurized, Alicia, you experience this. The pressurized suit can be put in different positions where it's sort of holding itself up, right?
Yep. So you kind of can find these neutral positions
Yep.
that, like you said, it kind of supports itself. So in that deep squat in that later video, you can kind of just sit. It's like you're sitting down on, like I'm sitting in this chair, and it supports itself. It's kind of really weird feeling. But then walking around, you can kind of like straighten your knees out, so yeah, that kind of neutral position right there.
Yep.
You can kind of like lock your knees. And I don't recommend that really, but like you can kind of stand your legs up straight, and the legs will take all the weight of it. And that's
Yeah.
really nice, right? And then I'm not wearing the weight on my shoulders or my waist. You kind of let the suit do its thing, right?
Yep.
And like I said, that's the programming, right? Is getting used to it. Is don't just sit there and hunch over and carry the weight of everything.
Yep.
Let it do its job, right? So you can see him
Don't
standing
fight
up
it.
here, kind of jumping, squatting, rotating the different bearings right here. Being able to do this is just wild, right?
Yeah,
Like all
that.
those videos of the Apollo on the moon,
Yep.
bunny hopping around, falling over, frontwards, backwards.
It looks like you could ski. Like you could ski in that
Yeah,
thing. There are some
yeah,
skiing motions happening there. So
yeah. I had my skateboard the other day, and they wouldn't let me get on the skateboard just to not be super safe. But that's part of it, right? It's like you have the ability to do a lot of stuff. I think I was even able to put my leg up on top of a chair to take a huge step. I mean,
yep.
you can climb up ladders, climb down stairs, upstairs, jump on an ATV, jump in a rover, right? Whoops, that's a little. That
That
little
was
part
just the
fell off.
demo thing. Yeah, that wasn't
3D
Oh
printed
yeah.
something like that.
The
there's
3D
a
printed
demo
demo
link
part. Yeah.
for it.
Nice.
But so yeah, so the amount of flexibility these guys have, and like you were saying, Alicia, you kind of felt like you didn't want to be too rough on it. You don't
Yep.
want to break it. You will break before the
I could
suit
not have
breaks.
if
You
I
will
tried.
break
Yeah,
before the suit does.
yeah,
Nice.
you will get beat up in there if you went crazy on it. And another really great example of going, I'd say, extra hard in this suit is we made had a great program that we oh shoot, what is the name of it now? But we sent a guy up higher than Felix Baumgartner on a balloon and
Okay.
free fell all the way. The Stratix program, sorry. If you look at the Stratix program, a private individual paid to have a suit developed and go even higher than Felix Baumgartner's like Red Bull jump that he
Yeah.
did. And so you kind of think about like how are you going to land this thing? I got a parachute. I'm going to land on my feet. Well, okay, the legs. You might not be able to get the legs out there perfectly. They said, all right, well, you can land on your feet, hit your feet first, and then go down onto your landing gear, and then your helmet's going to be your landing gear, right, and slide it out. But those helmet bubbles are so dang strong. I mean, I remember hearing stories of this. I obviously wasn't around then, but or with the company, but of them landing on the face of the helmet. And
Yeah.
everyone's, oh my gosh, we beat him up. Like he's going to be so beat up. The individual got up, said, "No, we're good. Let's go again.
We're good. We're
Let's
good.
pack the chutes again. Let's try another jump." Right. So, I mean, these things are just built so strong. And like I said, it's kind of just a heritage of those NASA standards, those NASA safety requirements. Is not only are we meant to take this pressure, we take a factor of safety on top of that,
Yep.
and then we take a lifetime. The fabrics are going to degrade over time, right?
Sure.
So, but even at the end of its life, it still meets all of those factors of safety, kind of deal, right? So, yeah, with his feet going like this, I mean, that doesn't almost looks unnatural. How flexible he is.
Yeah. You know what, this is great because we see so many pictures of the astronauts on the ISS, and it's like, gosh, that suit looks so bulky and big and crazy. But here we see it in context with regular people and business casual walking around, right?
Yeah.
And the thing that really got to me was the suits are not as bulky as I always thought they were. And maybe this is a difference between the older EVA suits and the new Astro suit. If you look at the people next to the suit, and me without a hat on, apparently, I don't know who cleared that for broadcast. The suit is not as bulky as I always thought it was. It's like person sized.
Yeah, it's actually impressive. If you find someone who like a decent size fit for the suit
Yep.
You look at them, you're like, it actually looks good on you. Like it actually looks really form-fitting. Look at an astronaut currently in space, Johnny Kim.
Yeah.
He did some of the coolest photo shoots that I've seen. Look him up on LinkedIn. He's in the EMU spacesuit,
Yeah.
still ILC's suit.
Yeah.
And I've never seen that suit look so good. I highly encourage all of you guys to go look at Johnny Kim. Not only is he like a rock star
Yep.
astronaut, and I'll leave it at that. I highly encourage you to go look him up. Just a super humble guy. He looks good in it too, man. Like it just looks like the right size. When you're kind of in and out of the suit, yeah, like okay, the pants look big on you because you're wearing a stretchy top, right?
Well, sure, yeah.
Okay. But like then you look at the arms next to it and the person inside of you, like, oh, it's actually not that bad.
It isn't.
It's not like you're like a big Michelin man walking around, barely can move.
Feel like that. It didn't feel like that, did it, Alicia?
No, like I was saying before, it actually is a lot closer than you expect. It felt comfortable, actually.
Yeah.
And I could swing when I was attached. I remember I could lift up my legs and kind of just like swing there for a second. That was fun.
Yeah. Here, y'all help me take my pants off. What is it? Is the LT, the lower torso LTA?
LC, yep, assembly.
Yeah, assembly. Lower torso assembly. Thank you.
Yep.
But even there, I don't walk around in like the skin tight. I mean, you don't want it to be skin tight on me, but that suit is tighter than most of my shirts and stuff that I would normally wear. So you put on like a regular shirt that has a little bit of bagginess to it, and it changes it a lot. We're like 12 minutes over the length of the show that we were supposed to do. Connor, have you not told us anything that you really wanted to talk about? Is there one thing where you're like, oh gosh, I always wanted to tell people this about the spacesuits? Is there anything we haven't touched on or asked that you were really hoping to cover in the show?
Yeah, I think you guys kind of talked about it throughout the time, right? But just to reiterate the kind of importance I think that ILC has played in the spaceflight industry, right? Is we're the original. I consider myself a little biased. That's fine. We're the original spacesuit manufacturing company, right? We've been making them since Apollo. We're the only company to go to the moon with a spacesuit. The only company to go to the ISS with a spacesuit. Yeah, for the American side. I guess there's another space. Anyways, is we have the heritage right here at ILC. And so you see this pressure garment behind me. Oh, this side. Pressure garment behind me is this truly, and this is no bias, is the most advanced spacesuit that's ever existed. Like I said, we can fit the first to 99th percentile in this suit. The mobility, the flexibility. This isn't just something that we just developed in the last year or two. This is something that we've been working on in partnership with even NASA for the last couple decades.
Right.
You know, we kind of see we went from Apollo spacesuit to the Space Skylab, Space Shuttle spacesuit, ISS spacesuit, and then now that's not like an empty gap in between those. We've been developing, advancing technologies that entire time. So not only are we big in the spacesuit game, obviously, but we have other opportunities for companies as well as space inflatable habitats. So not only for low Earth orbit, sorry, but also the moon. You could send up one of that big inflatable module to the moon, set up a base. That doesn't sound so bad.
Yep.
So we'll see here shortly. Like I said, we didn't really mention it too much, right? This suit was developed for NASA. It's currently not under contract with NASA, but that's I imagine that will change here in a little while. So don't be surprised if we're not the very first person back on the moon with this suit. But if you want a spacesuit to stay there, for sustained lunar operations, I think this is probably your best bet right here. So a little sales pitch there for you. But that being said, is we're not down and out with the spacesuit game. We're here and we're here to stay. And I can't talk about too much more of the next steps that we got going on, but I just highly encourage everybody to keep an eye on ILC here in the next year or two. We might have some really exciting announcements and some new products that will help, I guess, round out this product I have here behind me. So yeah, I'll leave it at that. But no, I really appreciate you guys coming out and not only last month trying them on, but having us online here again. And then I'd be more than happy to kind of sit and critique. We love to do that in the office.
We should do that.
Comes out and say, "Oh my gosh, what are they doing?" You know, sometimes they don't do so bad, but we love it here, and sometimes we nitpick on little things. But that's because we're the spacesuit company, right? I think we earned that right.
Yeah. Good deal. It really is amazing. There's so many things we didn't even talk about. Like y'all do inflatables like blimps and stuff like that you see flying over a sports game.
And
ILC does that.
you did like the airbags for the Mars rovers
Airbags for
too.
Mars rovers.
Yep, we've been to Mars as well, right? Yeah, so
Yep.
we've
You're
got
ready
a
for
lot of
Mars
history
already.
there.
Yep.
Yeah, to kind of touch on that, if you see any new Goodyear style blimps, we manufacture those. Those aerostat blimps that you kind of see on the border for border protection. If
Yep.
you go to South Padre
See
or
those at
Starbase, you see
Yep,
that thing
South
floating
Padre.
around. We also made that thing.
ILC.
Anything that's we call ourselves the soft good experts, right?
Right.
If you need it manufactured out of something soft, I think we're the leading experts in that industry. We also make ray domes for giant radar installations. The
Okay.
military has some of those on some big old vessels and on land as well. We make those covers as well.
Yep.
Different masks, different for jets, fighter jets. We make some of those masks for those folks. We have a lot of stuff, right? And so obviously I'm biased because I love the space suits and I want to do this forever if I can. Man, this is it right here. If anybody wants to know more about spacesuits, you're at the right place.
You're at the right place. Good deal. Connor, we got the right person on the show today to just talk to us about all sorts of different things. There's lots of questions we didn't even answer that came through the chat, but we talked about so many different options here and so many different things, the technicalities in the suits. It just had a good conversation today. Thank you so much for spending the time, especially on your weekend. It's Sunday today. You took time out of your weekend to hang out with Alicia and I and all the folks that are watching as well. So thank you so much for being a part of the Astro Live today.
Yep. Thank you, guys. Thank you.
And also, if you guys want to check out those clips that we were showing you, the full live stream of that, you can find that on YouTube as well, on NSF's channel. It's called Live on Location, Sizing Up ILC's Astro EVA Suit. So check that out, the whole video. We were there for like 3 hours or something.
We were there for a while, yeah.
And just talking about all of the details of that and what it felt like. And you can hear us talking inside the suits and everything. It was amazing. You guys were the best. Thank you so much for that opportunity as well again.
Yep.
Glad to have you guys.
Deal. All right. Well, Connor, we've taken more time than we had expected here, but I do believe, Alicia, what do we got going on next month? We've got more Astro Lives happening.
So first of all, as you may know, back in June, again, I mentioned we opened up a brand new exhibit called Mysteries from the Deep, Exploring Underwater Archaeology. It's co-produced by the Intrepid Museum and Flying Fish, and it is an immersive exhibit inside of our space shuttle pavilion, and it really dives into this other extreme environment of the deep sea. So it's all about underwater archaeology, some of the cutting-edge technology that they use to find things, and also just how teams of experts are able to work together to uncover these mysteries that they find from thousands of years of history. So shipwrecks and fossils and all kinds of really cool stuff. So if you happen to be in the New York City area, be sure to come by and check that out. It is open through January. And it's free with admission, so please come check that out. And it also kind of ties into our next month's Astro Live theme. You might have noticed there's been kind of a trend here since last month. Of course, we did Neutral Buoyancy Lab last month, and then the suits this month. By the way, the suits that they use underwater are not soft goods. So actually ILC might not be the best for that. They're like made out of like hard aluminum. They look like the spacesuits, but they're like very rigid. I would imagine difficult to maneuver as well. But anyway, next month we are going to be talking about this really cool underwater space connection that we stumbled on. You've probably heard of the Bermuda Triangle, right? So in 2022, there was a team of explorers who went on an expedition to look for the wreckage of something called Flight 19. It was the squadron of Navy bombers that went missing during a training mission in 1945. And then also the rescue plane that went to find them also went missing. But they went out to try to find this wreckage. But what they ultimately ended up finding was a 20-foot fragment of the Space Shuttle Challenger. So NASA confirmed it. They went out, they were like, yep, this is legit. And it's actually the first major Challenger artifact that they've recovered in over 25 years. And it's big. So we are actually going to be having two of the main guys from that expedition on to talk about that whole experience, what they were looking for. Also a really neat connection to the Intrepid because they were looking for this squadron of Avengers that we actually have an Avenger plane on our aircraft carrier. But then they found, this piece of the space shuttle as well. And of course, we love shuttles here on NSF and the Intrepid channels, right? So they're going to be on. This story was actually featured also on the History Channel a few years ago in a series that they had about the Bermuda Triangle. Ooh. So anyway, come on, check it out next month. This is going to be October 19th at 3 p.m. Lost and Found: The Mystery of Flight 19 and Space Shuttle Challenger.
Excellent. As always, all sorts of different things going on here, and we are very happy that we're able to bring it to y'all remotely. Like, not everybody can get to the museum every weekend, can go and see these things in person, but that's why we have experts like Connor come onto the show and explain things to y'all here on the virtual Astro Live. Again, big thanks for everybody watching, whichever channel you were on, whether you're on the social media channels for the museum, over on Facebook or Twitter or the YouTube channel there, or you're over on the NSF channel, or if you're watching my channel over on Twitch. We're still putting these over on Twitch. Appreciate y'all as well. But we are so glad that y'all are able to support us. And also, you noticed on the stream today, there was a fundraiser going on, and I saw a couple donations for the fundraiser there. Those are going over to support Intrepid Museum's programming, educational programming like this. Alicia, we got that set up for today when we were getting things in, and I did see a couple coming through. So thank y'all.
Thank you for your support. Yeah, that goes towards our educational initiatives just like this. So we really appreciate it.
Yep, not just for showing up, but financially supporting what we do. That is going to be the end of our special show here, Astro Live. Another one coming up next month, like Alicia said. Connor, let's get Connor back here one more time and tell him thank you, because he gave us so much time out of his weekend. There he is. Connor Chappell, spacesuit engineer, ILC Dover. Thank you so much for taking time out of your weekend with us. We appreciate you, man.
Yeah, thank you guys. And just lastly, just want to, I'm not just the only person here, right? Everybody here in Houston and in Delaware. Obviously, this is all thanks to them. So just a huge shout out to everyone in ILC Dover.
Good deal.
Absolutely. And a huge shout out to everyone in your particular facility as well for, again, inviting us in to get all of that amazing footage and letting us do
everything,
crazy things while we were there. It's amazing.
Exactly. We'll see if we can't take you up on that spacesuit movie critique with actual spacesuit engineers. I think that would be a successful series if y'all are down for it. But there you go, folks. That's the end of today's Astro Live show. We always appreciate y'all hanging out with us. Thank you so much for watching. Hope you learned something. Hope you appreciated the show. Hope you had fun with it. But for now, that's the end of this one, and we will see you nerds later. Thanks for watching.
And here we go.
Chamber pressure looks good.
Rolling up.
They go down to nominal.
Flight downside FD off. FD off. It's orange.
Orange 25. Oh my god. Oh my god.
Decollage.
Look at this.
Put that in the big bag.
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane would be igniting the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.